And hello, welcome to this video. So this is okay. In this video, I want to make a note about how the polling actions work. So let me delete this layer. Yeah, I want to make a video about how these polling actions works. So what are polling actions? What do I mean by that? So last time we actually had this function. Okay, I'm going to run this function. And this function actually prints out the endpoint every 3 seconds. So 1, 2, 3, print. 1, 2, and 3, and print. So every 3 seconds, it will print out this address for us. So the question I had in mind, because I want to develop an application that's kind of time sensitive, is that when you have a polling action that takes 3 seconds, and maybe this is some sort of time graph, 3 seconds. Okay, polling action that takes 3 seconds, and let's say your execution time was 100 milliseconds, right? Maybe 1 or 200 milliseconds. Okay, maybe 200. Okay, so the question is that, is this polling action, this time limit, is it inclusive of this 200 milliseconds? Is it over and above 200 milliseconds, or is it under? Okay, so to find out this question, I want to do some experiments and demonstrate that. Okay, so we'll make a new live demo called polling action time testing or something like that. So I'm going to copy this over and I'll call this the polling action time test test.rs polling action time.rs. So I'll change this to demo number 5. I'll call this polling action time. So this, again, what I'll do is I am going to the modules and I'm going to pop this module polling action time. Okay, and I'm going to include the use of that. Pop use live demo polling action time test, and I'm going to include whatever's in there. Okay, so 19 down. I don't want to run this. Don't run server, and then I'll put a demo file polling action time, and this will be run. This server will be run. So I'm going to take a look at this polling action time and let's do some experiments. Okay, so we know already that this thing actually takes 3 seconds. Okay. Yeah, this address is printed every 3 seconds, so we can use that as a baseline. Okay, we can use that as a baseline. Right. So just for your information, these polling actions actually run asynchronously in an asynchronous manner. So just to demonstrate, I can do a 9-second timer. Okay. So I'm going to do this. Let 9-second timer equals to, okay, move. I'll make a closure like so, and what I'll do is that I'll use a sleep function, a thread. So I'll use this use standard thread, and I'll use a sleep function. Okay, so the duration will be if we go here, we can use this time duration from milliseconds. So time duration is as follows. Let duration equals to this time duration from milliseconds, and we will sleep about 9 seconds. Okay, we will try to sleep for 9 seconds, and of course time is not used, so we'll try to use standard time, and this should actually work. Okay, it says expected expression. Oh, right, it's a syntax error. So I wasn't paying attention. I'll delete this, and it should work. So this 9-second sleep timer will run every this timer will run every 9 seconds, or rather maybe I'll just make the polling action. I won't use the sleep one first. So print line, okay, and I'll just say 9 seconds reached. Okay, so something like that. A 9-second timer that executes every 9 seconds. Okay, so what I'm going to do is I'm going to add the polling action of 9 seconds. So if it runs asynchronously, we should see 3 addresses being printed before it says 9 seconds reached. So 9,000 milliseconds here, and I'll do a 9-second timer. Okay, so what we should see, if both threads run asynchronously, is that we will see 3 of these addresses before the 9 seconds is reached. Okay, so the first one, both of them actually run at the same time. And then we see three ticks. Okay, see 3 ticks of the opcua server, and then we have the 9 seconds reached thing that's actually printed. Okay, so this shows that, you know, this shows that the thing, what this polling actions actually run asynchronously, but the polling actions themselves actually, if you see the 9-second timer, you do not see them run asynchronously. Each polling action runs synchronously, all right, well, with each other. So so this 9 seconds timer it shows us that polling actions run asynchronously if the polling actions are different. Okay, next thing is that, okay, if these polling actions run asynchronously, what happens if we, you know, so-called add some time to it? All right, so for example, if I want a polling action to take maybe 12 seconds, right? So what am I talking about? Okay, so just now the question was, does the polling action time add to any of the execution time or the sleep time? All right, or is it inclusive of this time? So if it is if the polling action time is in addition to the execution time, what it means is that, all right, if I include this sleep thread, this sleep action, so this actually makes the execution time about 9 seconds, makes the execution time about 9 seconds, and the polling action time will also take about 9 seconds. All right, so what happens is that if the execution time is added onto the polling action time, so the polling action time here is 9 seconds. If we have a sleep time of 9 seconds, okay, plus 9 seconds of a polling action, so what we should expect is we have 18 seconds. All right, so we assume that that's the case, okay, but as we will find out, you will see that this is not the case. So what I'm going to do here is I'm going to make this thread sleep for 9 seconds, and then after that I'm going to add the polling action with a 9-second interval. Okay, I'm going to save this, and let's see how this thing on the right hand side change. How does it change? All right, so okay, we have our OPC server. It will tick 3 times, so 1, 2, and 3. So this is the first time they coincide. Okay, so 1, 2, and 3. So you see another 9 seconds reach. So 9, then 1, 2, 3. Yeah, so and there'll be 3 OPC TCP printouts every 9 seconds. So that actually shows that the total execution time between each of these polling actions here, it is not 9 plus 9, rather it is just 9 seconds. So this polling action time frame of 9 milliseconds or 9 seconds is actually inclusive of all this time. So if this thing actually takes the full 9 seconds, the polling action will re-execute again immediately. So let's say, so that means if I change this sleep time to 3 seconds, I change this sleep time to 3 seconds, it will still be every, I mean, it doesn't make a difference because this execution time is less than the polling action time. So once the thread finishes executing, it will wait until the full 9 seconds expires, and then the polling action will run again. Okay, so you see that it waits like it prints it out 3 times before it says 9 seconds reached. Okay, so what happens if we actually overshoot the polling action time? So let's say I put a 12-second timer right here. Okay, if I do a 12-second timer, what I should expect is that the IP address actually prints 4 times before having this 9 seconds reach. And instead of 9 seconds, of course, I should be saying 12 seconds. So let's put the duration here, and then I'll just put this. Okay, so duration, so as seconds, I'll use this function, and this will be a float 64. So it should print 4 times. So let's take a look at the right hand side. So this is the first time. So it prints 3 times, and then the 4th time they coincide. See, the 4th time they coincide. So 1, this is the first one, second one, okay, third one, and then the 4th one. Okay, 12 seconds reach. So you can see that if the execution time inside the closure exceeds the polling action time, it will actually what do you call that? It will actually just execute again immediately. Okay, it doesn't have to wait for this. It doesn't end an extra 9 seconds. But if the execution time exceeds 9 seconds, the server will just run the polling action again. So that's how this polling action time actually works. And of course, if you get the thread execution time down to even 1 second, okay, if you get the execution time down to even 1 second, it will actually wait the full 9 seconds before printing out that 1 second again. Okay, so you wait 1, 2, 3, and then see, it prints out the 1 second. Okay, so this is sort of how the polling actions timing and scheduling work. Yeah, it's just good information, and hopefully it helps with programming. Okay, so that's it.